Hello guys, today we are taking the trigonometric functions or integrations. If we have cosec x whole power 4 dx, then how will you do this? We break this as cosec square x and cosec square x, and we know this cosec square x in terms of square. So cosec square x equals to 1 plus cot square x. We substitute this, and right now we have this expression, and in this case we will substitute cot x as t, and the differentiation of cot x is minus cosec square x. So the value of cosec square x dx is minus dt. So we put this, it is 1 plus t square, and this is minus dt. So it is t cube by 3 plus t plus c. So we get minus cot cube x by 3 minus cot x. So this is the final answer. Cos x to the power 5 dx. When we have the power in odd number, so we extract a single power, like we break this cos x to the power 4 into cos x dx. If we extracting the cos x, then remaining part should be in terms of sign. So we can write this is cos square x square and this is cos x dx. Right now we can convert cos square x in terms of sign. So it is 1 minus sin square x. On substituting this value, 1 minus sin square x whole square, and this is cos x dx, and right now we will substitute sin x as t. So the differentiation of this is cos x dx is dt, and this becomes 1 minus t square whole square, and the value of cos x dx is dt. Right now this is in terms of t, and so its integration with respect to t is very easy. Now expand this, we get t to the power 4 minus 2t square plus 1 dt. So on integration we get t raised to power 5 over 5 minus twice t cube over 3 plus t plus c. So we substitute this value, sin x to the power 5 divided by 5 minus 2 by 3 plus sin x plus c. So this is the answer. Now the next question, integrate under root 1 plus sin x. So we put the value of 1 as sin square x by 2 half angle formula, cos square x by 2, and the value of sin x will be 2 sin x by 2 cos x by 2. And this is the formula of a square plus b square plus 2ab. So it is a plus b whole square right now. Under root and square will be neutralized, and we get the result cos x by 2 plus sin x by 2. Now on integration we get the standard integration of cos is sin x by 2, and it is divided by the differentiation of this substituted part, so it is 1 by 2. When we integrate the sin x by 2, the standard integration of sin x by 2 is minus cos x by 2 divided by the differentiation of substituted part, that is half, plus c. So it is 2 sin x by 2 and minus 2 cos x by 2 plus c. So this is the answer. Integrate sin x into 1 minus cos 2x. So as we know this, the value of 1 minus cos 2x by the trigo formula, it is twice sin square x. So we substitute this value, that is 2 sin square x dx. Right now root 2 as a constant comes out, and this is sin x, and the under root sin square x is sin x, so we get finally sin square x. Now we will multiply and divide by 2. As we have earlier discussion, the integration of sin square x, we try to convert this in terms of cos 2x formula. So it is this 1 minus cos 2x is 2 sin square x. So right now the integration of 1 is x, and the standard integration of cos is sin 2x, and the substituted part is 2x. Then we will divide by the differentiation of substituted part, that is 2 plus c. So this is the answer. Cos 4x and sin cube x. So this is even number and this is odd number. So always we will try to extract the one power from the odd number. So it becomes, we break this as sin square x into sin x. And if the extracting part is sin x, then the remaining part should be in terms of cos. And the value of sin square x in terms of cos is 1 minus cos square x. So we put this, and this is remaining cos x to the power 4, and this becomes 1 minus cos square x, and the extracting part is sin x dx. Right now we multiply this, we get cos 4x minus cos 6x and multiply it with this. Right now let cos x equals to t. So on differentiation we get minus sin x dx equals to dt. So when we substitute these two values, this and this, so cos x as t, so it becomes t to the power 4 minus t to the power 6, and this sin x dx, right now this becomes minus dt. So we put this value, and as a result when we multiply minus inside, then we get this result. So on integration of t to the power 6, we get t raised to 7 over 7 minus t raised to 5 over 5 plus c, and when we substitute this value, then it becomes cos x whole power 7 divided by 7 minus cos x power 5, and this is the final answer. So the theme of this question is this: if we have cos and sine with different parts, so we will extract the odd number power and extract the one power from that odd power, and remaining, if sine x is extracting, then remaining question should be in terms of cos. If cos x is extracting, then remaining question should be in terms of sine, and then we let the sine x or cos x as t, and we will do this question. Now the next question is, if we have fractional power with sine and cos cube x, and this is the odd power, so we will extract 1 cos x from this question, from this part. It is 2/3 x, and this is cos square x and cos x. If we extracted cos x, then remaining question should be in terms of sine. So we substitute the value of cos square x as 1 minus sine square x. Now we have the change in this question is 1 minus sine square x in place of cos square x. So right now we multiply this, we get sine 2/3 minus sine, it is 6 plus 2, 8/3, and it is cos x dx. Right now we substitute sin x as t, so its differentiation is cos x dx equals to dt. So we have this value, and sin x as t, so we put this value, t 2/3 minus t 8/3, and the value of this is dt. Now on integration we get t 2/3 plus 1, and this is 2/3 plus 1, and there is t 8/3 plus 1, and this is 8/3 plus 1, so it becomes 5/3, and this is 5/3, so we get 3/5 t 5/3 minus this is 3/11 and t 11/3. So we substitute this value as t. It is 3/5 sine 5/3x and 3/11 sine x 11/3. So this is the answer. Now we have a question. It is integration of sine cube x and cos cube x. So we extract a cos from this expression. Right now we have sine cube x and cos square x. If we extract cos in this type of expression, then the remaining question should be in terms of sine. So it is sine, but this is cos square, so we convert this as 1 minus sine square x, and this is cos x dx, and this becomes sine cube x minus sine x to the power 5 cos x dx. And right now we substitute, we assume sin x as t, so this becomes cos x dx is dt. So the value of this is dt, and we substitute sin x as t, so it is t cube minus t raised to 5 dt. So using the power formula we get t to the power 4 over 4 minus t to the power 6 over 6 plus c. Again we substitute the value of t as sin x in this expression. So we have sin x to the power 4 divided by 4 minus sin x to the power 6 over 6 plus c. So this is the answer. Now next question is sin x to the power 7 dx. So when we integrate this, we will extract a sin x from this. So right now we break this sin x to the power 6 and sin x dx. And if we extract sin, then the remaining entire system, entire expression should be in terms of cos. So we can write sin x to the power 6 as a sin square x cube, and we can convert this sin square x as 1 minus cos square x. So it is 1 minus cos square x cube sin x dx. Right now we consider the cos x as t, and on differentiation we get minus sin x dx equals to dt, or we can say sin x dx is minus dt. So the value of sin x dx is minus dt, and we put cos x as t. So this becomes 1 minus t square whole cube and minus dt. Right now minus comes outside, and when we expand this, we will collect the expression, and when we adjust this minus, we get t to the power 6 minus thrice t raised to the power 4 plus thrice t square minus 1 dt. Now we integrate this t to the power 6, we get t to the power 7 over 7 minus thrice t to the power 5 over 5 plus thrice t cube by 3 minus 1 integration is t plus c. Now we put the value of t as cos x, that becomes cos 7x by 7 and thrice 3 by 5 cos x raised to the power 5 plus 3 will be cancelled out, so cos x cube minus cos x plus c. So this is the answer.